Welcome to the second video on tangent ratios. This video we're going to have a little bit more practice calculating using the tangent ratio. So we have our right triangle, GHJ, and we saw in the previous video that angle G, we found that by taking tangent G equaled opposite over adjacent, 4/5. And to find it on our calculator, we take the inverse of tangent G. So we take the inverse tangent of 4/5, and we came up with 38.7 degrees. So angle G is approximately 38.7 degrees. But what if I asked you to find now angle alpha? And there it is, right there. Which one is the opposite? Oops. Well, let's look at our triangle. Let's draw our triangle back in. Got a little crazy with my eraser. So angle alpha, the opposite now, is 5, and the adjacent is 4. So for angle alpha, I have to take tangent alpha, and my opposite is 5, my adjacent is 4. So that means that my inverse tangent of 5/4 in my calculator will give me what that degree is. So if I put in inverse tangent, 5 divided by 4 in my calculator, I'm going to get approximately 51.340. So I'm going to round that to a tenth of a decimal point, so 51.3 degrees. Let's have you try. I want you to find angle A with our triangle ABC with the length AB equal to 3 and BC equal to 8. Pause the video and come back for the answer. Welcome back. I hope in your calculator you put inverse tangent of opposite over adjacent. And if you did, you should have gotten approximately 69.4 degrees. Let's look at a second example, more of a real-world situation. So I have a house, and since I'm such a green individual, I want to put a solar panel. This is my solar panel on the roof of my house, so I don't have to rely on city electricity. I want to generate my own. And I know that my roof line, it's 9 feet, and the space between where I've marked the middle of my roof line to the edge of my roof here is 12 feet. So what is this angle here? And I'm going to call that angle A. What is angle A? And is it going to be enough for my solar panel? Well, angle A, I have to find the tangent of A, and what is my opposite? It's 9. What is my adjacent? It's 12. So I'm going to calculate that through on my calculator. Inverse tangent, 9/12. And if you put that in, remember, second function tangent for your inverse tangent, 9 divided by 12, and you should get 36.8 Now I'm going to round it to just 1/10 of a decimal. Whoops, 36.9. So let me write that in a little bit neater. 36.9. That's better. Now, why is this important? This is important because if I had told you that the best angle of inclination, which is this angle here, so the definition of angle of inclination is the line or line segment, which is the acute angle it makes with the horizontal. So here's my horizontal, and I'm looking there. That's the angle of inclination. If I told you the best angle of inclination, so the best angle I should have is approximately 60 degrees, would my roof line provide the best design for my solar panel? In this instant, no, it wouldn't, because as we can see, my roof line provides an angle of 36.9. That is significantly less than the 60 degrees, which is optimal. So I probably wouldn't want to put my solar panel on my roof. I'd probably want to construct something off to the side that holds my solar panel at the 60-degree angle. So I'd probably have to put in a nice little post to support it and then angle it that way, which would be somewhat a pain because then I have to run wires. But that's an aside. So we can use the tangent ratio to find the angle of inclination. And that is the point of that story.